Hello to everyone. In today's lesson, we'll try to reveal the prime constructors of composite numbers. In other words, we'll factor composite numbers into its prime factors. If a number is not prime, I mean if a number is composite, then you need to think about its prime makers at the back of your mind. Of course, there are many non-prime numbers, but some of them are very special and can help us understand this subject more than the others. This is according to me. This is my idea. For example, 360 is one of them. There are various methods to do this applied in mathematics. Now, let's start by working on a non-prime number, on a composite number, in other words, and I think you understood which number I'll use here. Which number? Yes, 360. Now, I told you many things in this course, in this video. The most important sentence here is the following. If a number is not prime, you need to think about its prime makers at the back of your mind always. You should think this. Now, let's continue with the method. How you may factorize a composite number into its prime factors. The first method here is the following. This method is the best one for me. And I'll use the product strategy here. The number you know, 360, and you may write 360 as the multiplication of 36 and 10. It's 36 times 10. After that, what about 36? 36 is 9 times 4. Am I right? And 10 is 2 times 5. After that, sorry about it. 9 is 3 times 3. 4 is again 2 times 2. And the remaining is 2 times 5, right? Is times 2 times 5. Check all numbers. All numbers, one by one, if you check, are prime. So I cannot write one of them as the multiplication of any other numbers except 1 and itself. For example, 3. 1 times 3. It's not meaningless. Okay. It's meaningless. Sorry, it's meaningless. 1 times 3. If you write 3 as the multiplication of 1 and 3, or 1 times 3, it's meaningless. So all numbers are prime and I reached the result. I have 3 2's here in multiplication. 2 times 2 times 2, it means 2 to the power of third, times 3 times 3, I have 2 3's here in multiplication, it means 3 square, and only 1 5 in multiplication, 5 to the power of 1. I don't need to write here 1 as the exponent. Now I have just finished the operation. This is the prime factorization of 360, and I made 360 by multiplying the prime factors, prime numbers 2, 3, and 5. I have 3 2's, 2 3's, and 5 in multiplication. Okay, if you multiply 3 2's with 2 3's and 5, you will get 360. Now the most important is the following: 2, 3, and 5 are the prime factors of 360. Okay, or prime constructors of 360. Now this is the product strategy, and you may apply easily to any composite number. Okay. Now let's continue with the next strategy or next method. Prime factorization method, and again use 360. Now there is a line like this, vertical line, right here 360, and we'll divide 360 with prime numbers. The smallest prime number is 2. Is it possible to divide 360 with 2? Yes, because 360 is even. It's divisible by 2. If you divide a number with 2, it means you should find, as the result of course, you should find the half of it. The half of 360 is 180. What about 180? Is it possible to divide 180 with 2? Yes, because it's even. The half of 180 is 90. 90 is also even, so divisible by 2 again. 45. Half of 90, yes. Now, after 3 2's, I divide 360 3 times 2. 2 over 2 over 2. Now I reach 45 by dividing. And 45 is an odd number, so it's not divisible by 2. After 2, I should continue with the next prime number, next smallest prime number, 3. Now I should check whether 45 is divisible by 3 or not. And by the rule, if the sum of digits of a number is divisible by 3, then that number is divisible by 3. What is the sum of 45 digits? Sum of the digits of 45. 4 plus 5, 9. Is 9 divisible by 3? Yes. So 45 is divisible by 3. Let's divide 45 with 3 in another place. In 4 I have only 1 3. 1. In 15 I have 5 3's. 5 times 3 is 15, and the remainder is 0. So if you divide 45 with 3, you will get 15 without remainder. Right here, 15. Now, what about 15? Is 15 divisible by 3? Yes, we know from multiplication table that 3 times 5 is 15. So if you divide 15 with 3, you will get 5. And 5 is prime. So after 3, 5 is not divisible by 3, of course. After 3, pass to 5. 5 over 5 is 1. Now, our aim here is to reach by dividing with prime numbers 1. I should reach 1. When you reach 1, the process will over. Okay, we'll finish. So I have just finished this operation, and I reached all prime factors of 360 here. I have 2, 2, 2, 3 2s, 2 3s, and only 1 5. If you multiply these numbers, you will get 360. So write here the result. 360 is equal to 2 times 2 times 2. It means 3 to the power of third times 3 times 3, 3 squared times 5. Only 1 5. I don't need to write here 1 as the exponent of 5. Without writing, you mean it's 1. So this is the prime factorization of 360 by prime factorization method. General method is this. You may use for any composite number this method to reach the prime factorization. Now let's continue with the next page and the last method. But this method is for kids. Don't use anywhere. If your teacher wants, please use this method. Which method? Making prime factor 3. But to this operation, to start this operation or this method, start with a smaller number. For example, 24 maybe. Now I wrote here the number 24. And is it possible to divide with 2? Yes. The smallest prime number right here, 2. 2 times 12. Because of being 2 times 12 is 24. I wrote in the next balloon 12. Now 2 is prime. So I cannot write as a multiplication of any two numbers without 1 and 2 itself, because it's prime, you know. So it's meaningless writing again 1 times 2. So what about 12? 12 is also divisible by 2. And 2 times which number gives you 12? Of course 6. And now this 2 is also prime. What about 6? 6 is divisible by 2 again, and 2 times, because of 2 times 3 is being 6, 2 times 3 is being 6. I wrote here 2, after 2, here 3. 2 times 3 is 6. Now 3 is also a prime number, so my operation has just finished. Show all prime numbers here. 2, 2, 2, 3 2s I have, and only 1 3. 24, 12, and 6 are composite numbers. And after that, if you multiply these prime numbers, you will get 24. Okay, so write the result. 24 is equal to 2 times 2 times 3. I have 3 2s, 2 to the power of third. I should write after that times 3. Now this is the prime factorization of 24. 2 and 3 are prime factors of 24. Now let's continue with the next example on the next page. Our famous number 360, and try to make prime factorization 3 here. It's divisible by 2. So 2 times which number gives you 360? 180. What about 180? 2 is prime, so don't make any operation on it. Is it possible to divide with 2? Yes. 2 times which number? 90 gives us 180. So 490 again apply. 2 times 45. What about 45? Is it possible to divide 45 with 2? No. What about 3? After 2, 3 comes, So right here 3, and if you divide 45 with 3 you will get 15. What about 15? Is 15 possible to divide 3? Yes. So 3 times from our multiplication table 5 gives us 15, and 5 at the end is again a prime number. Now let's remark all prime numbers 2, 2, 2, 2, 2, 3, 3, 3, and 5. Yes, I showed you all prime numbers. 360, 180, 90, 45, 15. There are composite numbers. But the remaining are all prime numbers. And multiplication of them gives you 360. So let's write the result for 360. 2 times 2 times 2. It means 2 to the power of third. 2 cubed, or times 3 times 3, 3 square, times 5. That's all. This is the prime factorization of 360, and 2, 3, and 5 are prime factors of 360. At the end you may tell this. Now after this operation, the first method is my best one, my favorite one. I am using the first method, product strategy method, in my mathematics life. So today's lesson is over. We'll continue this interesting subject on the next lesson. So hope to see you soon. Bye.